ear. The ear basically is encased in bone. By now you should realize it's temporal bone. Okay, you have the external auditory meatus and so on. All right. Now, type of thing that I would ask on the ear. The ear has three parts: outer, middle, inner ear. The outer ear is basically the earlobe here, and the auditory canal. Okay. The middle ear is basically your malleus, incus, and stapes, and the eustachian tube, and the tympanic membrane. So again, the outer ear is the earlobe and the canal, so that sound waves can come in. And actually, the outer part of the tympanic membrane or eardrum, okay, is basically part of the outer ear. Okay, the rest of it is middle ear. Okay, and then the two bones, the three bones, the ear ossicles, the malleus sits directly on the tympanic membrane. Okay, the tympanic membrane is the eardrum. Okay, I want you to use tympanic membrane now. Okay, so you have the malleus, then the incus. So you may remember them as the hammer, the anvil, and the stirrups, which is actually part of the middle ear, but it's attached over here on the model. Okay, so the hammer, malleus, the anvil looks like an anvil, the incus, and the stapes sort of looks like stirrups. So you'd put your foot in on if you were riding a horse. That's the stapes. It's middle ear, but they attached it to the oval window on the cochlea, because that's where it would basically, it would be the last bone to vibrate, and it would cause movement of the oval window. The other structure in the middle ear is this. It's called the eustachian, or the auditory tube. When you go up in a plane, okay, if you go up in a tall building, what happens to your ears? They pop. Okay, and they usually will tell you to chew gum or swallow or something, and it'll open up the eustachian tube. Okay, this is normally a closed tube, but the truth of the matter is, every time you yawn or swallow or talk or anything, it actually opens up the tube, and we know we get middle ear infections. It actually attaches the middle ear with the nasopharynx, okay, which is the throat behind the nose. Okay, and what it does is it equilibrates the pressure, so that when your ears pop, when you go up into a higher altitude, and you do something that opens the canal, you're actually equilibrating the pressure between the throat and the middle ear. Okay, and that's what happens in high altitudes. Causes you to pop your ears. Okay, and then the inner ear. Okay, the inner ear is basically your cochlea, the snail, which is for hearing. Okay, and then you have your semicircular canals and the utricle and the saccule for balance and equilibrium. Okay, so actually the ear it's pure sensory. Okay, but it's not only for hearing, it's also for balance and equilibrium. So the snail, okay, this big yellow structure is actually the eighth cranial nerve. Okay, we'll talk about that in lecture. Okay, that's the eighth cranial nerve. This part is actually the cochlea nerve for hearing. This is the vestibular part for balance and equilibrium. Okay, so it's called the auditory vestibular or acousto-vestibular nerve, or the eighth cranial nerve. So the cochlea is the snail. Okay, and the model on the wall there is actually, if you would have cut this, that's what it would look like. Okay, those are like sectioned layers, okay, of what you're seeing. Okay, so when you actually cut it, you can see, I'm not going to ask you the specific anatomy, but you can see the cochlear duct, you can see the scala tympani, and so on. Okay, and the organ for sensory, okay, in the middle, thank you, Vanna White, is back, it's known as the organ of Corti. That's for hearing. Now, as far as balance and equilibrium goes, okay, you got the semicircular canals, which are in three planes here. Okay, so these are for balance and equilibrium. Okay, these are for angular and rotational movement. Okay, angular and rotational because you've got sensory components here that can check things in three different planes. Okay, the utricle and saccule, which are down here, are actually for linear movement. So your sensory organ here takes care of different forms of movement. So when you're in a car, do you know when you're going forward or backwards? Okay, and you know when you're accelerating or decelerating? Okay, that's linear movement. Okay, that's the utricle-nasacule, and it's really these are called otolith organs. Okay, they have calcium carbonate crystals that respond to gravity. Okay, and when they pull and they move the hair cells in a certain direction, you're either moving forward or backwards, some linear movement. Okay, these, on the other hand, are activated in any angular or rotational movement. Okay, so if you go on some crazy ride, okay, or if you're thrown into total malequilibrium that involves rotation or angular movement, it's these. Okay, skaters that do spins, okay, ballet dancers that do spins, semicircular canals, okay, angular rotational movement. So, basically, there are tests that you could do. I wouldn't do it because basically I don't know how sensitive people are to equilibrium issues. Okay, but there are clinical tests where they put them in a chair that sort of really resembles a spin chair. Okay? Even astronauts go through those kind of tests. Okay? And basically you can exhibit or produce different effects. Like if I put you in a chair that spins, okay, and have you hold your head in a certain direction, and have your eyes closed, you'll feel like you're spinning out in space when I stop the chair. Okay, but what happens if your eyes are closed and then I suddenly stop you from moving and you open up your eyes? Nystagmus, rapid eye movement. Not REM sleep, which is rapid eye movement, liquid sleep, okay, but actual rapid eye movement back and forth. Okay, it's called nystagmus. Okay, and what it's about is the retina is trying to fix a point and actually, locate something because you've just been rotated. Okay, so the eyes try to fix on the retina at a given point. Anyone that actually is involved in those kind of movements knows that. Okay. What's the worst thing that you can do when you go on a ride?
Eat.
Huh?
To eat.
You mean before you go on the ride? So that would mean vomiting. Not the answer I was looking for, but basically close your eyes is the worst thing you can do. Okay, it makes the ride scarier, but what you're doing by closing your eyes is you're losing complete conceptual visual cues. Okay, by closing your eyes, you're losing all that visual input. Okay, so when you stop and all of a sudden you open your eyes, you don't know where you are. It's actually an interesting area, but we don't have a lot of time to really talk much about balance and equilibrium. I will talk about the 8th cranial nerve and hearing in lecture. So what I want you to do today, well, let me do the eye.